Let's go to Link 269, Alien Dictionary. So you see that there is a new alien language that uses the English alphabet. However, the order of the letter is unknown. So it gives us a list of string words from the aliens language dictionary, and it is said that these words are already sorted lexicographically by the aliens rule. And uh, so if by these words, right, you find some kind of contradicts, say that you cannot uh, have a correct rule, then return empty string. Otherwise, return a string of the unique letters in the new alien language sorted in lexicographical increasing order by the new language rule. If there are multiple solutions, return any of them. So what does the multiple solution mean? So So let's take a look at example. For example, this the AZ and the BX, right? We can return. We know A should be smaller or equal to B, right? But XZ or ZX both should be correct, right? So you'll see XZ or ZX is correct, right? So for this question, we know these words they are already sorted in alpha lexicographical order. So how can we determine which word, which character is precede has higher priority or preceding to another one? So we should compare the word by word, right? So for example, this is word I, this is I plus one. So what we do is that we try to also compare character by character, right? So W, the first one is W, the second one is R, the equal. The third one is T, right? Another is F. So we know T should be smaller than F, right? So we use T goes to F. So we always say F is dependent on T. So the second thing is that, for example, W, right, goes to E because this word and this word they differ for the first letter, and this one, the second letter, we know R should be greater than T, right? And the last one we know E should be greater than R, goes to R, right? So we'll see there is some kind of orders E, right? So we know this E greater than R, R greater than T, greater than F, right? So we know W, E, R, T, F should be some kind of order, right? So we'll see there is some dependencies. So this is some kind of graph problem. And because we know for those kind of dependency iterations, what we think of intuitively with is we use topological sortings, right? So if that we will say this W has in degree zero. After so we can put this one in Q, right? And then pull out. When we pull out, this is in degree should decrease by one. And then it has an degree to be zero. It can be in degree again, right? And we iteratively do these kind of steps until all of the words are able to pull out from the queue. So and when we pull this out, right, we just use a string builder, append this kind of word character to the string builder and return the string builder to string. So this is the concept. But there is some corner case, a lot of corner case for this kind of scenario, right? This, for example, if we have some kind of the last example three, right? So we'll say z goes to x goes to z again, right? This is a circle. Apparently, um, this is not a correct root, so it will return zero. So well, see, this has integrated one, this has integrated one again, right? So both have integrated one, and it will infinitely loop will never be go to in Q, right? So also we have, for example, x goes to y, y goes to z, right? Z go to x. If there is a circle, they will never go in Q, right? So what we want is that in the end, we will need for those kind of word or character which in Q and and the DQ, right? And we want to make sure this uh, string builder has include all of the words. Otherwise, we return empty string. And there is some other corner cases. For example, we compare this character by character, right? If in a scenario, the index comes to here, and all of the previous one are have the same character, but this one is longer. In this case, it will not be correct case. It should return empty string, right? So we'll say if all of the previous prefix are the same, we should have this one to be in the later order, right? So let's write code for this. First thing is that we need to have a map, graph. So we can have a set, and we call graph equals new hash map. And we are going to have a map character as integer integers plus new hash map. Because we want to, in the end, we want to make sure all of the characters are put into string builder. So we need to go through all of the word to see how many distinct characters. So when we go through this, actually we can for each character we can create those kind of sets, right? And also degree set that to be 0, so that we don't need to use a contains key uh, to determine whether we need to create a new set, right? So what we do is that we can use for string word in words, right? And for character say or char say in word to char array, right? So we're going to have a graph put say put if absent, right? Because it is possible it's already been put. Say new hash set. And also we want to have integrate put say as 0. Okay. Then we need to compose this graph and integrate integrate map. So what we do is that so to compose, actually we are compare the word I and word I plus 1. So what we want is int I equals 0, I smaller than words dot length minus 1, I plus plus. Okay, so we're going to have um so we're going to have a string word equals words I, in the next word equals words I plus 1, right? Then we compare character by character. We have length equals max dot mean word dot length and new word dot length, right? As um as we want to compare character by character, there is some scenario that the prefix are the same, right? So if we have index G from 0 to this L, right? If it already goes to L, then that means they have the same prefix. So we put this J outside. And when we put outside, if we have a word length greater than after this for loop, if we have the word length greater than new word next word dot length, that is invalid, right? So we can write for J smaller than L, J plus plus. So um char C1 equals word dot char at J, and C2 equals next word dot char at J, right? So let's say if C1 doesn't equal to C2, then we should do something, right? And we are going to do something in the break. Break, right? And also we'll say if J equals L, right? And there is word dot length is greater than next word dot length, right? This is invalid. So we just return empty string, right? And here, if C1 doesn't equal to C2, that means C1 is lexically smaller than C2, right? So what we do is that if graph it C1 doesn't contains C2, then we're going to have a graph it C1 add C2, and also C2 should integrate add one, right? So this will be the way to compose graph. Then we need a queue. So we need a queue character queue equals new array dict. So we need to find those integers equal to 0, right? So from map dot entry character integer entry in integers entries set, right? So if its value equals to 0, so if entry dot get value equals 0, then we need to enqueue queue dot offer entry dot get key, right? Then what we need a stream builder, and we need to keep importing and offering data to a queue. So stream builder equals new stream builder. So while queue is not empty, so we are going to have a character C plus queue dot pull, right? And also we need to have stream builder append C. And we'll say for um character uh next C under graph get C, right? So we're going to have in degrees merge next C -1 integer dot sum, right? So let's say if in degrees get next C equals 0. Then in this case, we need to enqueue again, right? Queue offer makes the character. So in the end, actually, if there is a cycle, that means some of the word, some of the character, they are not in queue, right? So for example, A goes to B, B goes to C, C goes to A. They all of the character have the integrate one. So what we need is that we need to return string builder dot length equals of course, this is just the graph dot size, right? Because originally we created this one. That is how many different characters graph dot size. If it equals, just return string builder to string, right? Otherwise, means it's invalid. Let's try to see. So in degrees, put 0. C. So this is the next word mean G is smaller than LG. So if C1 doesn't equal to C2, then graph C1. This is C2, right? C2 degree in degree. So doing like this, we'll see this kind of graph. If this has we iterate every words, right, and also every character. So this will be the time complexity of the how many the word, for example, that is n word, the average length, right? So this is NL. And for this one, for the Q, right? For the Q, this is a linear operations. So if we have n age, right, and how many different characters, right, we are going to enqueue. So this is an OC, right, different number of characters. Well, so 26 maximum, right? So here. So this will be a linear ONL plus 26, right? And also space, space that will be this will be this is also linear, right? So will be O26 for graph and integrate that also O26, right? But yeah, I think so. So um so will be O linear time complexity. We can also write a Python code for this. Mm. We need a we can have graph equals default dict, right? And value will be a set, and also in degrees equals let's say this for word in words and for C in word. We're going to have a graph set default C and set, right? And also we're going to have in degrees set default C as 0. So then we need to compose a graph for I in range length words -1, right? And we'll have word next word equals words I and words I plus 1, right? Then we're going to let's have L equals mean um, length word and length next word. So we're going to have G equals 0. We can use a while loop while J is smaller than L, right? C1, C2 equals word G in the next word G. So if C1 doesn't equal to C2, we have if C2 not in graph C1, then we're going to have graph C1 add C2. And also in degrees, C2 should plus equal to 1, right? And we should break because otherwise, for example, A, B, here, whatever you want, right? And then this is a character C1, this C2, right? So we can only compare these two. The first one, we cannot say because even here there is C2 or here there is C1. This is smaller. Otherwise, we'll get this one to be smaller. It will be incorrect, right? So we should break only for every adjacent words, we can only compare one character. And we are going to have G should plus equal to 1, right? So we'll say after this while loop, if G equals L and the length word is greater than length next word, this is invalid. So we just return an empty string, right? And then we do topological sort. We are going to have Q equals DQE deck. C for C in degrees. If in degrees C equals 0. Then what we do is the result equals empty list. While this is Q is not empty, then we're going to say equals Q dot pop left. And result should append this C. And we'll say for next character in graph C in degrees, next character should -1, right? So if we have in degrees, next character equals to 0, then we're going to have Q append next character. So in the end, we should return? Return join result if length result equals length graph, else that is an empty string.